Hi everyone, and welcome to another microeconomics mini lecture. The topic of this lecture is going to be price elasticity of demand, and also going to show you how to apply the midpoint formula. So first of all, what is price elasticity of demand? Well, this is just essentially the measure of how consumers respond to changing prices or to a change in price. And by that response, I'm talking about the quantity demanded and how changes in price will result in changes in quantity demanded. Now, there are two different determinants that will influence price elasticity of demand. And the first that we're going to talk about is the availability of close substitutes. Now, I've chosen to use an example here that I think many of you will be able to um, kind of relate with. I know that I can. And on your screen here, I have a picture of oranges, apples, and pears. Now, let's say that we are a shopper and we're going to the grocery store. On our grocery list, we have 5 oranges. Now, we go to the produce section, we have our bag ready, we're going to get the oranges, and we notice that the price has increased for oranges. Well, how do we respond? For me, I would start to look at my available options. So pears, apples, how are those priced? Are those priced more favorably? I know that I would likely end up purchasing fewer oranges and instead buy apples or pears. So instead of buying 5 oranges, I would probably buy 2 oranges, assuming price were to increase at this arbitrary level. And then I would buy instead a couple apples or a couple pears. And again, I'm not really getting too detailed or specific here. I'm just trying to paint a picture that you might be able to relate with or that might resonate with you. So the conclusion here, right, is that my demand curve, maybe your demand curve as well, for oranges is going to be relatively elastic, meaning that you will respond to the change in the price of oranges by purchasing a substitute good in its place. In the passage of time, this is really just referring to how consumers' tastes and preferences will change over time in accordance with different market circumstances. Luxuries versus necessities. I think this might be the most straightforward example I'm going to be going over today, but this is just where our demand curves are going to be elastic for those luxury items, in this case jewelry, and it will be inelastic or relatively inelastic for goods or products that are deemed to be necessary. So in this case, ambulance service. Now, what do these demand curves look like? Well, I have up on your screen a relatively elastic demand curve. Now, see that this demand curve is relatively horizontal or relatively flat. This just indicates that in response to changes in price, we're going to see proportionally greater changes in quantity demanded. Now, in addition to that demand curve, I put up a couple of price points and quantity points along some dashed lines to really help you visualize what's going on here. So when we see our price increase from P1 to P2, we're moving up this demand curve because our quantity demanded is changing. So we have our Q1 or quantity 1, which is associated with that price 1 or P1 point. Now we can visually see that the change in P1 to P2 is relatively less proportionally when we look at the change in quantity. This again is just an indication that the consumer response in this hypothetical market is relatively elastic. Perfectly elastic, this is going to really be unrealistic and more so theatrical and really aligns well with what you might have already learned about perfectly competitive markets. A perfectly elastic demand curve is perfectly horizontal, so perfectly flat. And what this tells us is that if price were to increase above this $15 market set threshold, or this market set price point, quantity demanded will fall to 0. If price is below the $15, then we're going to see that quantity demanded is infinite. And if price is at $15, consumers will buy it in any quantity. Relatively inelastic. This again ties back to what we learned about the ambulance and other essential or necessary goods or services. We're going to see that in response to changes in price, our quantity demanded is going to remain relatively constant, meaning that even if price were to increase, we're still going to purchase the same amount of those goods or services because they are necessary. We need to buy them. And assuming that we have the means to do so, we're going to continue to purchase those goods or services. So think back to the ambulance example. If we need an ambulance, regardless of price, we're going to pay for the trip. And we can visually see this by looking at our P1, our price 1, and our Q1, quantity 1, and how the change from price 1 to price 2 is proportionally greater than our change from Q1 to Q2. So this would be an indication of inelasticity. Perfectly inelastic, this is also similarly to perfectly elastic going to generally be unrealistic, but it's important that you can conceptualize what's going on here. So with this demand curve that is perfectly inelastic, we're looking at a perfectly vertical demand curve. And I do have a tip on here. One way that you can remember what the inelastic demand curves look like is that they look like eyes. So I for inelastic, they look like eyes. Easy enough, right? Now, what this tells us is that price could increase or decrease. It doesn't matter. The quantity demanded is going to remain completely constant at any possible price. Unit elastic, this is just where our elasticity equals 1. And what this means is that when we see a change in price, the change in quantity demanded will be proportionally equal. Now, we can measure elasticity by a few different approaches or means, but the most commonly used way by economists is the midpoint formula, which I have put up on your screen, and I'm going to walk you through how to fill this out and then further solve for the values I've inserted so we can derive our elasticity. Now, I should have probably emphasized this earlier. I did touch on how unit elastic is equal to 1. But going back through each of these, and I will keep this on the screen for the remainder of the lecture, but perfectly elastic demand, this is going to be where elasticity equals infinity. And for elastic demand, elasticity is going to be greater than 1. Perfectly inelastic demand is going to be equal to 0. Inelastic demand is going to be elasticity that is less than 1. And this will be important for later on once we get to our final result. But for the actual value that we determine for our elasticity, we are really looking at the absolute value here. So if our result is negative, it's really going to be thought in terms of absolute value. And we'll cover more of that here shortly. Now we do have a practice problem here that involves Jan in her bakery and what happens to the number of cakes that she sells after she changes her price point. So for our particular problem here, we have if a price at $20, Jan sells 20 cakes, and at $26, she sells 14 cakes. the demand for her cake is elastic, perfectly elastic, unit elastic, or inelastic. We need to set out to figure out which one of these answers is correct based on using that midpoint formula. I pulled back the midpoint formula, and now we're going to work through this formula by inserting the values for quantity and price. By now, I'm hoping you're familiar or comfortable with what Q1, Q2, P1, and P2 represent or mean. But just to kind of go back over these, P1, this is that initial price, so $20. P2 is the new price, $26. Q1 would be the initial quantity demanded that's associated with that initial price, so 20 cakes. And then Q2, or the new quantity demanded, is going to be associated with that new price point. So this would be 14 cakes. Now let's insert our values here. P1, like I said, this is $20. So this is our first price that Jan was using for her cakes. She then increased the price to $26. So $26 is our P2. Q1, our initial quantity, this is going to be 20. Q2, the amount that we sold, or that Jan sold after increasing her price, is 14 cakes. Now, to get from here to our final answer, most of you are probably going to be able to do this fairly easily. However, I have went ahead and put together a few more slides kind of showing you step by step how to simplify and solve for this formula. So 14 minus 20, this gives us -6. 14 plus 20, because in our parentheses, we can do that separate from the two that we are going to ultimately be dividing by. But 14 plus 20 gives us 34. 26 minus 20 gives us 6. 26 plus 20 gives us 46. So we have -6 over 34 over 2, and then we take the value of that, and then all of that goes over 6 over 46 over 2. But we can continue simplifying this, making it easier to digest. So we're going to keep the -6, but we're going to divide 34 by 2 and get 17. Then we're going to take 6, and we're going to keep it. 46 divided by 2 is 23. And then from here, we can just do basic division. And -6 over 17 is -0.35. 6 divided by 23 is 0.26. Now you might have noticed that I went ahead and dropped in those pipes or those bars, whatever it is that you refer to the symbols as. But this is just going to be a reminder for us that we're looking for the absolute value here. -0.35 over 0.26 is -1.34. Or again, we're looking at the absolute value. And we have 1.34 as our answer. Let's refer back down to our helpful reminders. What does 1.34 correspond with? Well, 1.34 is greater than 1. Therefore, we're looking at an elastic demand. Elastic is one of our options. That's our answer. So thank you all for watching. I hope that was helpful. If you have any questions about the midpoint formula or elasticity or any other microeconomics topics, please feel free to let me know. I'm happy to help. Thank you, and have a good weekend.